NASA plans to take humans back to the moon with Artemis. But what if it doesn't succeed? One small miscalculation, a single faulty component, and the entire mission could unravel. The consequences are far bigger than most people realize. This isn't just about a rocket failing. This is about humanity's next steps in space, and the stakes are enormous. Every decision, every calculation, every test matters more than most people can imagine. Most people assume that if a space mission fails, the problem is simple. The rocket blows up, astronauts come home safely, engineers fix the issue, and we try again. Sounds reasonable, right? But Artemis is nothing like Apollo 11. This mission has been decades in the making, costs billions, and depends on levels of precision humans rarely attempt. Think about the components: the Space Launch System, the Orion capsule, the Lunar Gateway. Each is a separate, highly complex system. Each has to function flawlessly. A single misstep could jeopardize the entire mission. And that's just the technical side. There are hidden challenges most people never hear about. These challenges can derail a mission before it even leaves the ground. Artemis is not just a rocket, it's a network of systems, each with its own risks. The Orion capsule must safely carry astronauts through space. The SLS rocket has to deliver Orion into orbit with perfect timing. The Lunar Gateway provides staging for the moon landing. The lunar lander must operate flawlessly in an environment with zero room for error. And then there's fuel, solar radiation, micrometeoroids, and unpredictable space weather. Engineers must account for every single variable. Artemis is not just engineering. It's risk management across millions of moving parts. Even small issues can escalate. A sensor malfunction could slightly miscalculate a trajectory. A software glitch could leave astronauts stranded in orbit. Fuel margins are tiny. Timing is critical. Launch windows for the moon only open at specific times. Miss it, and humans could be grounded for months or even years. Artemis is not forgiving. Every part has to be precise. Every calculation has to be double-checked. Every team member must perform perfectly. Beyond the technical challenges, Artemis is heavily dependent on international cooperation. Components come from multiple countries: rockets from the United States, modules from Europe, lunar landers from private contractors, and computer simulations from partner agencies. If one contractor misses a deadline or political tensions delay shipments, the consequences ripple across the entire mission. It's not just a scientific challenge. It's a logistical, political, and economic challenge, all at once. Imagine a domino effect. One small failure forces NASA to delay, restructure contracts, or postpone launches indefinitely. Funding is fragile. A failed mission could erode public support, and private companies could face serious setbacks. Artemis is a mission where human systems are as delicate as the spacecraft itself. The consequences of failure go beyond headlines. Human spaceflight relies on trust from the public, trust from international partners, and trust from political leaders. If Artemis fails, NASA's credibility could be compromised for years. Future missions, not just moon landings, but Mars expeditions, asteroid mining, and deeper space exploration could face delays or cancellations. Technology development is also at stake. Space programs drive innovations that impact Earth: robotics, advanced materials, satellites, and medical technology. When a mission fails, funding slows and innovation stalls. Artemis isn't just a moon mission. It's a technological engine that powers progress across industries worldwide. Every launch, every test, every mission pushes science forward, even on Earth. Artemis also tests human coordination. Engineers, contractors, scientists, and politicians all need to work perfectly together. Space is unforgiving. There is no margin for error. One misstep can become catastrophic. Timing, communication, and precision all matter. Success depends not just on physics and engineering, but on human skill, judgment, and careful planning. Think about the astronauts. Their training is meticulous. Every simulation, every emergency procedure, every check is designed to prevent disaster. But space is unpredictable. Micrometeoroids, solar flares, even tiny debris can put them at risk. The technology can fail, the humans can make mistakes, and the environment offers no safety net. So what if Artemis fails? Humans could be delayed decades in returning to the moon. Private companies could face setbacks. Future space programs could stall. Human ambition itself might face a serious test. But failure isn't the end. Humanity learns. Every setback teaches something new. Every attempt shapes our understanding of what it truly takes to explore space. One thing is certain, going to the moon is not simple. It is the ultimate test of human ingenuity, coordination, and resilience. Every detail matters. Every mission matters. Whether Artemis succeeds or fails, the lessons learned will define the future of human spaceflight for generations to come. And as we watch the rockets climb into the sky, we are reminded that space is both unforgiving and inspiring, a challenge that pushes humanity to its limits and sometimes beyond.